Ladies and gentlemen, the show starts in 3, 2, 1, go.
Magandang araw sa inyong lahat. Kami nga pala ang batang pasaway ng SB4A. Ako nga pala si James Carl A. Balyon.
At ako naman si Alan Morales.
At ako naman, si Alvin Jan, si Anastasio. At kung bago ka pa lang sa video namin, please like and subscribe.
And share.
At click the notification bell para lagi kang updated sa mga video namin.
Yo!
At ang topic na i-discuss namin ngayon ay frequency shift keying.
Frequency shift keying. Frequency shift keying generation. As its name suggests, a frequency shift key transmitter has its frequency shifted by the message. Although there could be more than two frequencies involved in an FSK signal. In this experiment, the message will be a binary bit stream, and so only two frequencies will be involved. The word key suggests that the message is of the on-off mark space variety, such as one historically generated by a Morse key, or more likely, in the present context, a binary sequence. Conceptually and in fact, the transmitter could consist of two oscillators on frequencies F1 and F2, with only one being connected to the output at any one time, unless there are special relationships between the two oscillators. Frequencies and the bit clock, there will be abrupt phase discontinuities of the output waveform during transition of the message. Binary frequency shift key. Binary FSK or 2FSK use two frequencies marked correspondent to logical 1, and then space correspondent to logical 0. Mark is the higher of the two frequencies. The distance between the carriers and the nominal center frequency, FC, is called deviation, FD or FC, or shift in BFSK. The bit rate is equal the baud rate. Each symbol, mark or space is 1 bit. Carrier amplitude does not change in FSK, only frequencies. Simplify amplifier design and selection, cheaper, more efficient. Bandwidth. Practice is for the tones F1 and F2 to be special in interrelationship and to be integer multiples of the bit rate. This leads to the possibility of continuous phase, which offers advantages, especially with respect to the bandwidth control. Alternatively, the frequency of a single oscillator, VCO, can be switched between two values, thus guaranteeing continuous phase, CP-FSK. The continuous phase advantage of the VCO is not accompanied by an ability to ensure that F1 and F2 are integer multiples of the bit rate. This would be difficult, impossible to implement with a VCO. Being an example of nonlinear modulation, calculation of the bandwidth of an FSK signal is non-trivial exercise. It will not be attempted here. Minimum FSK bandwidth is a function of frequency deviation, FD, bitrate, FD. Modulation index. Tone should be as close as possible without creating ISI. Modulation index, stand for H, is the ratio of 2x deviation FD to bitrate FB. Example, FD equals 20 kHz and FB equals 40 kilobytes per second. Modulation index is 1.0. decreasing FD to 10 kHz lower modulation index to 0.5, increasing FB to 80 kilobytes per second, also lower modulation index to 0.5. Optimal detection occurs when H greater than 1. Some coherent FSK variant can properly detect signal when H is below 1.0. Example, in MSK, minimum shift keying, H can be 0.5. MSK need less bandwidth than BFSK for a given bitrate. Application using FSK. Most common BFSK application is paging reliable and robust. Large FD, low FB. Also used for data collection, metering, telemetry, remote controls. Slowly being replaced by the other technologies, etc. QAM, SOQPSK for some application, much higher than data rates than FSK. Coherent and or filtered FSK variants are used in Bluetooth, DECT, etc. Application using MRE FSK. Many communication scheme based on MRE FSK. 6 FSK and 12 FSK Piccolo, 8 FSK Automatic Link Establishment, ALE, 4 FSK Two-Way Digital Radio Technologies, etc. P25, DMR, NXDN. FSK, because of simplicity and robustness, higher order, enables better throughput. MRE FSK. FSK that uses more than 2 frequencies is called MRE FSK, sometimes also referred as MFSK. The number of tones M is always even. 4 FSK, 6 FSK, 8 FSK, etc. Each tone represents log 2 M bits. Example, in 8 FSK system, each tone represents log 2 8 is equals to 3 bits. Most of the formula in this presentation can be adapted for use with the MRE FSK. Summary. FSK conveys digital data by shifting a carrier between 2 or more discrete frequencies. Binary frequency shifting, MRE frequency shifting. In coherent case, FSK, there is a smooth transition between states. Minimize spectral width and bit errors. Minimum bandwidth and space in carriers, often determined by bitrate. FSK is widely used in many applications. Robust and allow the use of nonlinear amplifiers but lower bit.
Yo! Nandito ako para discuss ang basic of FSK, definition of FSK, spectrum and bandwidth of FSK. Simulan natin yan sa basic of FSK. Ito ay ginagamit sa pag-convert ng digital data to analog data. Ano nga ba ang FSK? Definition of FSK, frequency of carrier signal varying with respect to amplitude of message signal. For example, meron tayo dito MT na message signal natin na digital na 1, 0, 1, 1, 0. And then, the high amplitude is 1, low amplitude is 0, 1, 1, and 0. And FC1, for example, meron tayo ditong FC1, and then FC0 natin, so yun. Ang DFSK natin ay ito sa 1, maghahati tayo dyan 0 and then sa 1. FC1, ang 1 represent ng FC1. So itong ano natin, signal na to. Tapos ang FC0, kasi ito bigit. FC1 again. and then FC0. So, yon. Simpleng definition of FSK. For value of 1, we send FC1 frequency, and for 0, we send FC0. Basic function of FSK. Is equals to message signal represent 0 multiplied by cosine omega C0 T plus pag 1 M1 T cosine omega C1 T yon MT equals to 1 FC1 then FC0 or 0 is FC0. Spectrum and bandwidth of FSK, we have amplitude here and frequency, and let's say we have FC0 here and FC1 here, and the band of FC0, this is the band of FC1. Yung gap dito, ng dalawa na to, is equals to 2 delta F. So the total bandwidth of FSK is equals to the half of this bandwidth equals to 1 plus D baud rate R over 2 plus another half of this bandwidth is equals to 1 plus D baud rate R over 2 plus the 2 delta F. 2 delta F. Ayan. Pag pinag-add natin tong dalawa na to, magiging 1 plus D baud rate R plus 2 delta F. For minimum bandwidth, D, the modulation is equals to 0. So if we plot this, FC0, FC1, frequency, amplitude, then this is 2 delta F. If we compute this 2 delta F here in minimum bandwidth, so we have half of this and then half of this, so 1 plus D plus R over 2 plus 1 plus D R over 2. So D in minimum bandwidth, D is equals to 0. So we have 1 plus 0 R plus 1 plus D 0 to 0 with 2. So 2 delta F is equals to R. So the minimum bandwidth of FSK is equals to R baud rate plus baud rate is equals to 2R. multi-level FSK, or in BFSK or binary FSK, we have the level of 2. So 2 raised to n, and n is equals to 1. Number of bits. So when L is equals to 4, 2 raised to n is equals to 2. When L is equals to 8, 2 raised to n is equals to 3. So, kapag meron tayong level na 2, ito ay mag-represent sa frequency ng FC0 and FC1. Pag 4, FC0, FC1, FC2, FC3. Then pag 8, FC0, FC1 to FC7. So the bandwidth in this BFSK is equals to 1 plus D times the baud rate plus 2 delta F. And if we have this level, for level L level FSK, the bandwidth is equals to 1 plus D times the baud rate plus L minus 1 multiplied by 2 delta F. Example, Xiaomi Philippines have an available bandwidth of 150 kHz, which spans from 500 to 700 kHz. What should be the carrier frequency and the bit rate if we have modulated our data by using FSK with D is equals to 1? We graph this amplitude, and then frequency, then 500 kHz, then 700 kHz. Then we bisect it, 600 kHz. Then we drop the band with this band represent zeros, and then this band represent ones. So if we bisect it, this represent to FC is equals to 0 is equals to 600 and 550 kilohertz. And then this represent to FC1 is equals to 650 kilohertz. And then this line from this to this represent to 2 delta F. So we can get this value by subtracting F0 to FC1. So 650 minus 550, we will get 100 kilohertz. This represents to 2 delta F. So now we have 2 delta F, and then we have a given bandwidth is equals to 150 kilohertz. Then the formula yung bandwidth. Bandwidth is equals to 1 plus D times the baud rate plus 2 delta F. Now we have a given bandwidth. Bandwidth is equals to 150 kilohertz is equals to 1, and D is equals to 1 plus 1 times R plus the 2 pi F is equals to 100 kilohertz. So we will get 50 over 2 times baud rate. So our baud rate is equals to 25 kilo baud rate. So we need the bit rate. Bit rate is equals to baud rate times N, where N is equals to in BFSK or binary frequency shift keying, L is equals to 2, where 2 raised to N, that's that, N is equals to 1. So we have N times the baud rate, so R equals to baud rate natin is 25 kilo times 1. So our R is equals to 25 kilo bytes per second.